Section 1, the greatest common factor and factor by grouping. So we're going to talk about factoring in this lesson. We've already talked about polynomials and multiplying and using that FOIL process by multiplying two binomials by each other. This lesson and this chapter is kind of the opposite of that. It's taking something that's written out and breaking it up into factors. And so the first thing we always do to factor is we look for the greatest common factor, the GCF. All right, so we kind of learn the basics of it, and then we'll put it into practice in a little bit. So the greatest common factor is the largest number, okay, that will go into both or into a group of numbers. So for example, on number 1, what's the largest number that will go into 28 and into 40? Okay, and there's multiple ways to do this. The way they tell us to do it in the book here is to go ahead and write out each number as a product of its prime numbers. Okay, which that means I want to take each number and I want to say, hey, can I break it down into numbers that will not break down any further? Okay, remember a prime number is a number that only way to multiply to get a prime number is by multiplying 1 in itself. All right, so if I wanted to define the GCF of 28 and 40, I can take the 28, and I can say, all right, what multiplies to give me 28? All right, different ways to do it, but I like to say 4 times 7, because that's the one I remember. That's 4 times 7. All right, and then take each one of those numbers and see, can you break those down any further? So 48 is 2 times 2. And 7 doesn't break down any further. So once you get down to a number that does not break down any further, you circle it, okay? And then those are your prime factorization. So 28 is 2 times 2 times 7. All right, then we can do the same thing for 40. All right, we can say 40, that's, let's see, 4 times 10? And then 4 breaks down into 2 times 2. And 10 breaks down into 2 times 5. And none of those, 2 is prime, 2 is prime, 2 is prime, 5 is prime. So each one of those are the prime factors of 40. So I could write 40 as 2 times 2 times 2 times 5. All right, and then once you write the prime factorization, you can say, hey, what do they have in common? They both have this pair of 2's in common, and they both have this pair of 2's in common. So each pair yields one of those numbers out of it, so we end up getting a 2 from the first pair and a 2 from the second pair, so our GCF is 2 times 2, which is 4. 4 is the biggest number that will go into both 28 and 40. Okay? Now, that's not the only way to do it. Okay? I could kind of think about, hey, what numbers go into 28? And since I know it's 4 and 7, I say, will 7 go into 40? No. Will 4 go into 40? Yes. Okay, the only bad or downside of that is sometimes you might miss something that's even bigger. All right, let's try 55 and 21. All right, so 55 is 5 times 11. So that's 5 times, and 5 and 11 are both prime. And 21 is 3 and 7. All right, and so you notice there 5 and 11 is not the same thing at all as 3 or 7. Okay, so we say, hey, the greatest common factor here for B, since they don't have anything in common, is just 1. Because 1 is always goes into something. Doesn't really help you a whole lot. All right, if you got 3 numbers, you just do all 3 of them. So 15, all right, turns out to be 3 times 5. That's the only way to do that one. All right, 18 Well, that's 2 times 9, and 9 is 3 times 3. So 18 is 2 times 3 times 3. All right, so really we can kind of see here that my greatest common factor is going to be 3, unless 66 doesn't have 3 in it. Okay, and 66 breaks down into what? 2 times 33, and then 3 times 11. So 2 times 3 times 11. So in that group, the only thing that they all share is one of those 3's. So my GCF here is 3. Okay. All right, take a second, pause it, and work out practice 1. All right, the answers are A is going to be 6. That's the GCF there. For B, their GCF is 1. And for C, the GCF is going to be 4. All right, now, if we have variables, the GCF of a list of common variables raised to powers is the variable raised to the smallest exponent in the list. All right, so what that means is if for A, I got x to the third, x to the seventh, and x to the fifth. Okay, those all have at least 3 x's. Okay, I'm not going to do this on every one of them. But if I had x to the third, I could write x to the third as x times x times x. That's what x to the third is. X to the seventh is x times x times x times x times x times x times x. And x to the fifth is x times x times x times x times x. And so what they share in common are 3 of those x's. All right, so all you got to do is say, hey, my GCF is the least amount that's in any particular one. So for B here, I've got y to the first, y to the fourth, and y to the seventh. The greatest thing they all have in common is that y to the first. Okay, because you can't have any more in common than the smallest one has. All right, try your practice 2. All right, here's your answer. A, I got y to the fourth because that's the smallest. And for B, I've got x to the first because that's the smallest in one particular problem. All right, now if you have multiple things, you got numbers and variables, you just do both of them. You say, all right, for the 6, 10, and negative 8. All right, they're all even, so they all have 2 in them. Anything else go into them? 3 goes into 6, but it doesn't go into 10. 5 goes into 10, but doesn't go into 6. 4 goes into 8, but doesn't go into either other one. So the GCF of the numbers is 2. All right, and as far as variables are concerned, got x squared, x to the third, and x to the first. So I take the smaller. So 2x is my GCF there. All right, for B, I go through here and say, all right, negative 18, negative 63, and 27. As far as GCF, negatives, you just kind of leave out of it. We might use the negatives when we do factoring polynomials. All right, but look here, and I remember that, hey, 18 and 63 were all in my 9's table. Okay, so 9 is going to be my GCF because 9 goes into all 3 of them. Okay, and then y's, I got y squared, y to the third, y to the fourth. Y squared is the lowest one, so 9y squared. All right, for C, I look at each variable separately. A, I got 3, 5, and 6. So the smallest one is 3. And for B, I got 2, 1, and 2. So the smallest one is 1. So A to the third times B. All right, try your practice. Go ahead and pause it. All right, so for A, I'm going to have 5y squared. For b, I'm going to have x squared. The 4, 1, and 3 coefficients have nothing in common. And the smallest exponent. And for c, I'm going to have a squared, because that's my smallest number of a's, and b squared, because that's my smallest number of b's. Okay, we're looking for factors, and so we can say, hey, can this be multiplied by something in order to give me each one of those terms? All right, now this is how we use it. Okay, we can factor out polynomials by saying, hey, what do they have in common? All right, so look at A. I've got 6t plus 18. There, 6 and 18 both are divisible by 6, so I can factor out that 6. And then what I'm going to do is I'm going to put a parentheses, and I'm going to write what's left over after I factor out or I divide out that 6. So I have t plus, and then 18 divided by 6 gives me 3. So we factored out that polynomial. Okay, and just think about it. We can check it by distributing it back through. 6 times t is 6t. 6 times 3 is 18. Okay, but that's what it means to factor out the polynomial. All right, for b, I've got just the y parts. So I take out the smallest amount, y to the 5th. All right, if I take away everything from a term, I'm left with 1. So y to the 5th, factored out the y to the 5th gives me 1. Put the minus, and then the y to the 7th, I've got 2 left over after I take the 5 out. All right, try your practice 4. All right, so that's going to be 4 times t plus 3. And then I'm going to have y to the 4th, which will give me y to the 4th plus 1. Okay, and remember with the way exponents work, I got four of them out, I'm going to have 4 of them left. Okay, you're not dividing the exponents. All right, example 5, I got more terms. All right, so I can factor out what they have in common. As far as number-wise, I've got a 3. Okay, and what I would actually do here, since that first term is negative, go ahead and factor out the negative as well. We'll see how that plays out in a second. And then the least number of a's is going to be that 1a, so I got 3a. All right, and then what I have left over in my parentheses, negative 9 divided by negative 3 gives me positive 3. Took out one of the 5a's, so that's going to give me a to the 4th. 18 divided by the negative 3 gives me a negative 6. Take one of the 2a's away, so I'm left with 1a there. And then negative 3 divided by negative 3 gives me a positive 1, and then I took the a out. All right, so it's factored like that. All right, pause and try practice 5. All right, here we go. I'm going to take out a negative 8 b squared. That's going to leave me with a b to the 4th minus 2b squared plus 1. All right, there you go. All right, let's do a little bit more of that. All right, I can take out 6 and a, which is going to leave me with a to the 3rd minus 2. Okay, 6 goes into 6 and 12. So it leaves me with a 1 and a 2, because 6 times 1 is 6. 6 times a negative 2 is 12. I took out the a, which leaves me with a to the 3rd and the 1st. All right, over here, 5 will go into 20, so I take out the 5. I go ahead and take out 1x, because they each have at least 1x. But the 5 is not in there in the first term, so I'm left with x, which will go to the 3rd power, because I'm taking one of the x's away. And then minus, I take out 20 divided by 5, which gives me the 4. The x is no longer there because I took it out. All right, let's do the same thing when you have more terms. All right, it's for 8. 8, 20, and 12. Those are all divisible by 4. So I'll take out 4. For A's, I've got one A here, so I'm going to have an A here. For B's, I've got 4, 3, and 3, so I'm going to take out B to the third. All right, and then what's left over? 8 divided by 4 is 2. I took one of the 2 A's away, so I got 1A. Took 3 of the 4 B's away, so I got B. Minus 20 divided by 4 gives me 5. I have A squared, because I took one of the 3 away. I took the B's out altogether. And then plus 12 divided by 4 gives me 3. I took the A out, and I took the B to the third out. Sum factored. Okay, try your practice 8. All right, here we go. I'm going to take 5 P squared Q to the third. That leaves me with 3 Q plus 4 P Q squared plus P. All right. All right, now this is kind of a setup for the next type of problems. All right. On these, you have written a little bit differently. I've got 5 and then a parentheses of x plus 3 plus y plus a parenthesis times a parentheses of x plus 3. So each of these 2 terms, here's term 1, here's term 2, they each have an x plus 3 in parentheses. So I can factor out that x plus 3, and then in my second parentheses, I can write out, hey, what's left in the first term after I take the parentheses away? That's a 5. And what's left over after I take the x plus 3 of the second term? That's plus y. And now it's factored. Okay, try your practice 9. All right, here's your answer. It'll be y minus 2 times 8 plus x. All right, same thing on example 10. You'll factor out an a plus b, because they both have an a plus b. And then in the first term, I'll be left with 3m squared n. And then since there's an understood 1 here, if there's nothing written, and that's all that's going to be left, I'm going to put minus 1. So 3m squared n minus 1. Try your practice. Here you go. You'll take the p plus q, which will leave you with 7xy to the third minus 1. All right. And so that gives us to factor by grouping. All right, and usually you're going to see this if you got 4 terms. Factor by grouping, you're going to group the terms into 2 groups so that they each have a common factor. Factor out the GCF from each group. If there's now a common binomial factor, like we saw in the previous examples, all right, we have a parentheses that's in common, we can take it, and if not, we can rearrange and try these steps again. Sometimes it won't work. All right, so the first thing you would want to do is say, hey, is there something that they all have in common? Okay, in this case, they don't. And so I've grouped them up into first group and second group. I say, all right, what do the first 2 things have in common? First 2 terms have an x in common. If I take the x out of the first 2, I'm left with y plus 2. All right. Now, since there's a plus here between the 2 groups, we'll put a plus. And then they both share a 3. They both have a 3 in common. So I take a factor of 3 out. I'm left with y plus 2. All right, and since I've now factored those 2 groups out, they each have that parentheses of y plus 2 in common. So I can factor that y plus 2 out, which will leave me with an x from the first group plus 3 from the second group. And there we have our factored polynomial. Okay, we're breaking this polynomial into factors, which is very beneficial later on when we're trying to solve equations. All right, practice 11, try it. All right, here you go. Factor a y out of the first group, which leaves me with x plus 3. I can factor a 4 out of the second group, which leaves me with x plus 3. So now I can factor out the x plus 3, which leaves me a y from the first term, 4 from the second. Okay, there you go. All right, here's just kind of a multiple problems here. Let's look at C12. All right, the first group has 5 and x squared in common, which will leave you with 3x minus 2. And then the second group has a 2 in common, so put plus 2, which will leave me with 3x minus 2. And now I can factor out the 3x minus 2, which will leave me with 5x squared plus 2. For 13, I'll look at the first two. Let's see, all right. They both have an x in common, so let's take an x out. That leaves me with 3x plus 4y. All right, and then since I got minus, I'm actually going to take a negative out of both of those. That's the only thing these two share, actually, is a negative. So if I take the negative out, that gives me the 3x, and then that second one also turns into positive because I'm dividing that negative 1 out. Okay, you can think about dividing a negative 1 out. And so now my parentheses are exactly the same, and I have 3x plus 4y. And then left over would be x minus 1. All right, and then for 14, let's see, the first group has an a in common. So it leaves me with 2a plus 5b. Second group really has nothing in common except for just 1. So I can put plus 1 times 2a plus 5b. All right, and that allows me to factor out that 2a plus 5b. So I have 2a plus 5b times a plus 1. All right, go ahead and try your practice. Go ahead and pause it. All right, here's your answers for those. For 12, I can factor out, let's see. Factor out 8. X squared out of the first two. Let's do this with 5x minus 3. I can factor out a 3 out of this, or 3 out of the second ones, which gives me 5x minus 3. And so you'll end up with 5x minus 3 times 8x squared plus 3. All right, for 13, you can factor out a y, which would give me 2x plus 3y. You can factor out a minus 1 or negative 1, leaving me with 2x plus 3y. And then you're left with 2x plus 3y times the y minus 1. All right, and then for 14, all right, they got a squared in common for the first group. So a squared times 7a plus 5. And then we could go ahead and just put a 1 out in front of the 7a plus 5 in the second group. And so you're left with 7a plus 5 times a squared plus 1. All right, just some more practice here. All right. So let's see. 3x plus y and 2 and 3x minus 2y. They really don't have anything in common in those groups besides a negative. So let's try this. Let's try 3xy. Let's just reorder. 3xy minus the 3x. And then we'll put, let's see, minus 2y plus 2. Okay, so I just kind of reordered everything, and if there's a minus in front of a term, that minus stayed with it. Okay, and then I can go ahead and factor out. The first group, they have a 3x in common. So if I do that, that factors out as a y left over from the first, and then minus 1. Alright, now I set up the second group with the y part first, even though that's kind of out of order of the original, because I was kind of looking ahead and saying, hey, this first term had a y in this group, so let's go ahead and put a y in the first term of this group. Alright, they both have a 2 in common. I'm going to go ahead and factor out the negative as well. So I take out the negative 2, I'm left with y in the first group, and if I divide a negative 2 out of the second part, it gives me a minus 1. And so now my parentheses are the same. So I can take out the y minus 1, which will leave me with a 3x from the first minus a 2 from the second. Alright, and for 16, let's see what's happening here. Alright, if I factor out a 5 from the first group, that leaves me with x minus 2. Alright, if I take an x squared out of the second group, that leaves me with x minus 1. Those two parentheses are not the same, so that doesn't work out. Okay, I can try, I don't know, the 10 and the x cubed really don't have anything in common. So the only really pairing up I can do is doing x cubed with the 5x, and then maybe the minus x squared with the minus 10. Alright, and if I factor x out of the first one, that leaves me with x squared plus 5. I factor a negative out there, that leaves me with x squared plus 10, and still the parentheses aren't the same. Alright, and so if that is the case, you can say this is prime. Okay, there's nothing that they can do to factor this one out. Alright, then finally for 17, the last one for this section. Alright, first things first is I can notice that all of the terms have a 2 in common. 4, 4, 2, 2. So I'm going to factor out that greatest common factor of 2 first. That's really what you want to do on these, is factor out the greatest common first. So that's going to leave me with 2ax minus 2ab minus bx plus b squared. Alright, and then now I can group. I can say, alright, these first two have a 2 and an a in common. Alright, so I'm going to have this 2 hanging out in front from the GCF. A little bracket here, because I don't want to confuse my brackets parentheses. Alright, then that first group has a 2 and an a in common, which I'll factor out, leaving me with x and then minus b. Alright, and the second one I can factor out, they both have b's in common. Alright, and for sign purposes, I'm going to take out a negative b, which will leave me with x, and then I'll have to change this sign because I took out a negative b minus. I have that 1b left over. And so now the parentheses are the same. So factored out, I have the 2 for my GCF, the x minus b that both of the other terms share, and then what's left over is 2a minus b. Alright, try the practice 17. Factor out the GCF, factor by grouping, and you're done. Alright, so they all have a 3 in common. which leaves me with xy minus ay minus 2ax plus 2a squared. All right, I can factor out a y from the first two. So it leaves me with x minus a. And I can factor out a negative 2a from the second one, which will leave me with x minus a. So my final answer, I have 3. I'll have the x minus a that both of those two terms share, and then y minus 2a from the leftovers. All right, good luck. Try these on my math lab. Email me if you have any questions.